when you compare and order fractions, excuse me, you need to have common denominators. Okay, so unfortunately for some of you, 4.4 was not your strongest showing. Okay, and 4.4 is the main thing that you've got to know. Well, actually 4.3 and 4.4 are the main things you got to know to be able to compare and order fractions. Okay, so I want everybody to make sure, go ahead and turn to, in your book, turn to section 5, chapter 4. Okay, turn to section 5, chapter 4 in your book. Let's look at number 2. Number 2 says 9/16 blank 3/4. And they want you to insert greater than, less than, or equal to sign. Okay? Well, before we do that, we really need to make them be equal. Okay? This one, it's probably easy enough to maybe see logically, and there'll be cases where you can do that, but you need to get in the habit of going ahead and making each fraction have the same denominator, because the bottom line is, in about 2 sections, we're going to be doing that all the time, okay, because we're going to be talking about adding and subtracting mixed numbers and fractions. Okay, so it's best that you go ahead and learn it and get as much practice as possible, even on the easy ones, because eventually you're going to have to do it quite a bit. Okay, so what then I have to look at is this. I have to look at the two denominators, and I have to ask myself, what is the LCM, 4.4, okay, what is the LCM of 16 and 4? Okay, now, first thing you got to remember is what is an LCM? An LCM means I'm going to count by those two numbers. Okay, so I heard somebody say 2. No, 2's not a least common multiple. 2 is a common factor, but it's not a multiple. In other words, I'm going to count by 16, 32, 48, 64, so on and so forth. Okay, or I'm going to count by 4s, 4, 8, 12, 16, and it's the first number I run into. The first number you run into is 16. Okay, so the LCM of these two fractions is 16. Now I have to use what I learned in 4.3 and make two equivalent fractions. Well, the fraction on my left, 9/16, this stays 9/16 because it already has a denominator of 16. The fraction on the right, I have to ask myself, what did I do to 3/4 to make it equal to 16? What did I do to 4 to make it equal to 16? Multiplied by 4, so I have to do the same thing to the top. Multiply by 4, that gives me 12/16. Now it's very obvious which one is larger. 12/16 is larger than 9/16 because 12 is larger than 9. So therefore, I put the greater than sign in there. Okay? Is it? Okay, less than sign. At least you're paying attention. All right? So, let's look at another one. Let's see here. 6/13 and 2/5. Six 13ths and 2/5. Now, this one's fairly easy to find the common denominator because both my denominators are prime numbers. 13 and 5 are both prime. So when you run into denominators where both the numbers are prime, then you simply multiply 5 times 13, which is equal to 65. And so that is my common denominator. 65 is the common denominator. So now we ask ourselves, what did I do to 5 to make it 65? Multiplied by 13, so I must do the same thing to the top number. 2 times 13, 26. What did I do to 13 to make it 65? Multiplied by 5, so I must do the same thing to the top, which makes it 30 over 65. So therefore, this time it is the greater than sign that goes in the blank. No checking to see if you're awake on this one. Okay? So obviously those are not very hard examples. Okay? We'll do some harder ones here in a few minutes. Let's look at the next thing we're going to talk about, and that is ordering fractions from least to greatest. Okay? Ordering fractions from least to greatest. Okay? Let's see here. 3/4, 2/5, 5/8, and 7/10. Okay? Now, there's a couple of different ways that you can do this. The way that always works is finding the common denominator with all the fractions. Okay? Yeah, that could be a little complicated. It's really not in this particular example. Another way to do it is by the process of elimination. Okay? And that's just basically using common sense or logic. Okay? People have trouble with that. Okay? So I will do it both ways. I'll show you both ways. But the first way, we just use a little common sense and logic. Okay? 2/5. Okay, is 2/5 larger or smaller than 1/2? Smaller. Okay, because half of 5 would be what? 2.5. So for it to be that fraction to be equal to 1/2, it would have to be 2.5 over 5. Okay, well that 2 is less than 2.5. So this one is less than 1/2. Well, aren't the rest of them more than 1/2? Okay, so I already know then what's the smallest fraction? 2/5. So I can go ahead and put it down as the smallest fraction because 2/5 is less than 1/2. All the rest of them are more than 1/2. Okay? Now, from this point, you could still use common sense. I can use it because I simply know what the fractions are. I know which ones are bigger and which ones are smaller because I know what they are as decimals. Okay? We really haven't talked about, we're going to talk about that in 4.7, changing fractions to decimals. We haven't really talked about that. But I can look at this. 3/4 of $1 is how much? 75 cents. Okay? So we know that's on up there. Okay, we look at 5/8. What is half of 8? 4. So that's just barely bigger than 1/2, right? 5/8, 4/8 would be 1/2. 5/8 is just barely above 1/2. Okay? 7 over 10, if I had 7 dimes, how much is that? 70 cents. Okay? Because that's 10. 1/10 would be a dime. So we know that this is smaller than 3/4. So we know that 3/4 then has to be the largest one. So 3/4 is the largest one. We said that 5/8 is just barely above a half. Well, what's half of 5? I mean, what's half of 10? 5. So that's quite a bit higher than that. So then we have 5/8, 7/10. Now, that's using just some basic common sense and logic. To do it the other way, to find the common denominator, okay, what I would need to do is this. I would have to find the common denominator of 4, 5, 8, and 10. Common denominator of that is 40. So I'd have to change each fraction to have 40 on the bottom. Okay? So what did I do to 4 to make it 40? Multiplied by 10. So I have to multiply the top by 10 because it has to be 10/10 as we discussed the other day with equivalent fractions. This fraction here, remember, this fraction here must be equal to 1, or the fraction it is no longer the same or equivalent. Okay? So what is 10 times 3? 30. What did you do to 5 to make it 40? Multiplied by 8. So that would be 8 times 2, 16. What did I do to 8 to make it 40? Multiplied by 5. So that would be 25. What did you do to 10 to make it 40? Multiplied by 4. So that makes that 28. So the smallest is 16/40, which is 2/5. There it is. Okay, we got that one right. The next smallest will be 25, which is 5/8. That's correct. The next one is 28/40, which is 7/10. That is correct. The last one is 30/40, which is 3/4. That is correct. So our common sense, logic way came up with the correct answer. Now, when you're putting the answers down, do not use the equivalent fractions. Okay? The answer must be the original fractions from least to greatest. Okay? In other words, don't put 16/40, 25/40, 28/40, and 30/40. Use the original fractions. Okay? All right, let's move to another one of those examples of ordering. I'm going to move down into let's look at 22. 22 says 3/7, 1/3, 1/2, and 9/14. Now, what I would encourage you to do is I would look at this from a number line where that is 1/2, that is 0, and that is 1. Okay, I would encourage you to look at that because it's easy to convert a fraction into 1/2. Okay, or a lot of times it's easy to see whether a fraction is smaller than 1/2 or greater than 1/2. Okay, as we look at these four fractions, okay, as we look at these four fractions, one of them, A, is 1/2. Okay, so we know that 1/2 falls there. Okay, is 1/3 more than or less than 1/2? Less than. So we know that 1/3 falls on this side of the equator. No, the 1/2, okay? Now, what about 3/7? Well, how you know whether or not a fraction is less or more than a half is, what is 1/2 of 7? 3.5. So then this is more than 3, so 3/7 has to fall on this side as well. Now, I'm not saying yet that 1/3 is less than 3/7. I'm just putting them on one side or the other of 1/2. Okay? Well, what is 1/2 of 14? 7. So that is 9 is more than 7, so that means 9 over 14 has to fall on that side of 1/2. Well, having done that, I already know what my two largest fractions are. What are the two largest fractions? 1/2 and 9 over 14. And I know that 9 over 14 is more than a half. Okay? So I can go ahead and do this. I can go ahead and say 9 over 14 and 1/2 are my last two fractions. So that only leaves me then with 1/3 and 3 over 7, because these are less than 1/2. So now I just come up with a common denominator, 3 and 7. Well, is 3 prime? Yes, 3 is prime, because it only has 1 and 3 as factors. Okay, is 7 prime? Think before you speak. Yes, it is. Okay, so I can just take 7 times 3. That's equal to 21. So that's my common denominator. Okay, so I'm going to take and make two fractions. And I really don't like sort of just all over the place here on my screen, but for this one I'm going to do that. For the next one I won't do that. But I want to change this fraction to have 21 on the bottom. I'm going to draw a little line there so we know what the different. Better yet, I'm going to scoot this over. Okay, so if I convert 3 to 21, what did I multiply by? 7. So I do the same thing to the top. 7 times 1, 7 times 3. 7 times 1 is 7. I'm going to do the same thing to this 7. What do you do? Multiply by 7 to get 21? 3. So I'm going to multiply by 3 to both the top and bottom, and that gives me 9. So that tells me 1 over 3 is the smallest, 3 over 7 is the next smallest, then I have 1/2, then I have 9 over 14. Okay, now I could have gone in there and figured out what the greatest common factor, what the least common multiple of 7, 3, 2, and 14 is. Okay? And if I did that, what would be the LCM? Anybody know? Zach? 42. So I'd have to convert all the fractions to 42, then convert all the numerators to their equivalent with 42 as the denominator. Okay? But I was able to keep from doing that by just using some common sense and logic. Okay? Now, I know a lot of people that have a hard time with common sense and logic that are very intelligent people. Okay? We have a student here at this school that's probably one of the most intelligent people we have in high school, but when it comes to common sense, they have a little issues. Okay? But they can, seriously, they're probably the smartest person in high school. Okay? But when it comes to common sense things like, can't think of an example right off the top of my head, but they do have trouble with common sense. Okay? But they would blow you out of the water now, and they would blow you out of the water probably when you get to their age in high school. Now, let's look at 5/12, 3/4, 19/36, and 7/8. Okay, I say that a while ago to say that common sense is not a gauge on how much intelligence you have. Okay, there's some very, very intelligent people in the world that, common sense is not their forte, but they would, their intelligence level is very, very high. And you find that quite often. Quite often people that are very intelligent don't necessarily have any common sense because they look at everything from a intelligent standpoint instead of a, okay standpoint. I get that.